Number 13, right here, they're asking us to subtract. It's simply combining like terms. The easiest way to do this is to take that minus sign and distribute it to each term, which means they change to a positive 8 and a positive 3i. After that, it's really just a question of combining like terms. The complex number has to have the real part first, so let's combine the real parts first. The negative 7 and the positive 8, that is positive 1. And then go for the imaginary parts. We have a plus 9i with a plus 3i. That's plus 12i. So this will be our answer. 1 plus 12i, which happens to be option B. Let's move on to the next one. Number 14. Right here, it's really easy. It's just distributive property. Remember, an I is treated exactly like a x, right? X times x is x squared. X times x to the third is x to the fourth. The only difference is that the I squared equals negative 1. So let's just treat it like an x for the time being. 2i times 3, that'll give us a 6i. And then 2i times negative 6i, well, 2 times negative 6, it's negative 12. And I times I is I squared. So we really have 6i minus 12i squared. But what we need to remember is that I squared is really a negative 1. So I really have 6i minus 12 times negative 1. So that's really a 6i plus 12 because a negative 12 times a negative 1 is positive. And now the only other thing you need to do is write the real part first, the 12, write it first, and the positive 6i second, which means that that is option A. Let's move on to the next one, number 15. Simplify. All we have to worry about, kind of like radicals, is not having a radical in the denominator. In this case, not having an imaginary number or a complex number in the denominator. So if you want to get rid of i's, when you have a binomial with an imaginary, a complex number, you want to get rid of that, you're going to have to multiply by its complex conjugate. Now, the complex conjugate is simply the same exact binomial, but what? You change only the middle term sign. Only the middle term sign. So, of course, we're going to multiply both top and bottom. So, you're going to have a negative 5 up here, plus 5i also. So, let's work on the bottom part first. So, negative 5 times negative 5 is positive 25. Negative 5 times positive 5i, that's negative 25i. And then, let me change colors here. Negative 5i times negative 5, that's positive 25i. And then negative 5i times positive 5i is negative 25i squared. Now, when you combine the middle terms, they always cancel out when you multiply a binomial by its conjugate. and the last part, the I squared, that's really a negative 1. So what do I really have? I have 25 from here, and then I have minus 25, but this is now going to be a times negative 1. So I really have 25 plus 25, which is 50. So you have 50 in the denominator, okay, because we've only been working on the bottom. This is the bottom part, the denominator. Let's go back up to the top part and work on that. So if I distribute negative 1 times negative 5, that's positive 5. Negative 1 times positive 5i is negative 5i. And then negative 3i times negative 5, that's positive 15i. And then negative 3i times positive 5i, that's negative 15i squared. Please let me know if I mess up. So let's continue to simplify by combining the middle terms. In this case, they do not cancel out. So I will have a 10i right here. The I squared is negative 1. So we have a negative 15 times negative 1. That's really going to be a plus 15. And let's also not forget about the plus 5 way out in the front. So on the top, what I really have is 15 plus 5 with the 10i. So on the top, I really have 20 plus 10i. So let me rewrite this thing. On top, I have this. On the bottom, I have this. So I have 20 plus 10i over 50. Now, we could simply cancel out all the zeros, make that a little easier. No, I'm sorry, we can't cancel out all the zeros. Or could we? Yes, we could cancel out all the zeros because all three terms have a zero. So what do we have left? We have 2 plus I over 5. Whoa. 2 plus I over 5. And we can't leave it together. A complex number is always going to be separate, with the real part first and the imaginary part second, which means that you have a 2/5 fraction plus 1/5 I. That is option D. Moving on to number 16. Okay, that's 20. Let's move on to number 16 up here. Find the product. Ladies and gentlemen, this one's going to be fun. Why? Because it's a binomial, and they want us to expand it to the third power. That's right. We're going to have to move to Pascal's triangle. Pascal's triangle is a triangle of ones. 1 plus 1 is 2. Put the ones on the outside again. 1 plus 2 is 3. 2 plus 1 is 3. Put the ones on the outside again. And remember, this one is the power of 0. Power of 0 equals 1. The power of 1 gives you these coefficients. Power of 2 gives you those coefficients. Power of 3 gives you these coefficients. So I'm going to stop right there because this is a power of 3. What I need to do is write these coefficients followed by 2 parentheses after each number. So I'm going to have 1 parenthesis, 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 plus, and let me just pause it and write it all. So there's the setup, and now we have to do the powers. So the highest power is 3, which means that the first parenthesis is going to have the highest power of 3, which means that the second parenthesis is going to have the power of 0. And as you go to the next one, the 3 has to decrease by 1 to become a 2, and the 0 increases by 1 to become a 1. Moving on to the next one, if the iPad gets unfrozen, you gotta be kidding me, we're stuck. So there it is, filled out with the correct powers, and now all we have to do is plug in the values into the parentheses, and those values are 3x and 4y. So we plugged in the 3x and the negative 4y into each of the parentheses, and we'd have to work all of these out. But you know what, guys? There's a shortcut because it's multiple choice. Let's take a look at these multiple choice options here. So here we are at number 16. We know that it is not going to be B or D because that's only 2 terms. We know it's a ginormous term. Not only that, we also know that there's a minus sign in the binomial, which means that the signs of the answers are going to alternate. So what does it have to be even without doing any work? Has to be A. So that's ridiculously easy without doing all the work. But of course, if you're bored on a Saturday night, go for it. Do all that other stuff right there. But for the test, you could use logic. Understand that the minus sign means the signs will be alternating on your answers. Let's move on to number 17. Find the values of x and y that make the equation true. So it's just a question of plugging in x and y and seeing which one works. So let's start with option what? Pick one. A. So if we plug in x being negative 2, we would have 11 times negative 2 plus 5i equals negative 22. I'm sorry, it's not times, it's plus 20y, and y is 1/4, so 20 times 1/4, which is going to be 5 times I at the very end. So what I really have is negative 22 plus 5i equals negative 22, and this is really 5, so plus 5 with the I, and that's the correct option. So if it didn't work, just try the other ones, keep plugging in until you get one that gives you a true statement. Moving on to number 18. Number 18, rewrite the polynomial in standard form, then identify the leading coefficient, the degree, and number of terms in the same polynomial. Okay, so standard form implies that you start with your highest exponential term, which happens to be the power of 5. So let's start this by writing it as in order from highest exponent down to smallest. That would be this one first, and then this one, and then the power of 3, and then the power of 2, and then x, which is negative 2x, and then the constant at the very end. So there's the polynomial written in standard form, highest exponent down to the constant, and it's asking for us to identify several things, like the leading coefficient. What's the leading coefficient? Negative 6. So it cannot be option A. Actually, just by looking at it, it's either going to be, well, what's the answer? It's D. You don't even have to think about anything else because that's the only one written in standard form. To number 19, it's solving the inequality. It's a quadratic inequality. And I don't know if you guys remember how to solve quadratic inequalities. You have to pretend that it's an equation. So you're going to pretend it's an equal sign. And you're going to solve it as if it were an equation. And if that were the case, you would want to set it equal to 0. So subtract 13 to both sides. My bad, I'm sorry, that is a negative 13, so I will be adding 13 to both sides. Okay, that is a negative 13, which is right here. So that's a negative 13, so I'm going to be adding 13 to both sides. So my new equation will be, there's my new quadratic equation. You could use the quadratic formula, or even easier, since it's equal to 0, you could divide everything by negative 3. And get a new quadratic equation, x squared plus 2x minus 3 equals 0, which means that you could factor, split, and solve. So you'd get x, what times what is negative 3, that if you add together 0, that'd be a positive 3 and a negative 1, which means your two answers when you split it and solve will be x equals negative 3 and x equals 1. However, these are not answers. They're only critical values. You need to go to a number line and put them on a number line. Put the negative 3 on the number line, the positive 1 on the number line, and you have to test values. Which number would you guys like to test?
0.
0 is definitely between the two critical points. If we test 0 by plugging in 0 for x, up here, 0 squared is 0 times 3 is 0, 0 there. You'll have negative 4 is greater than negative 13. So since negative 4 really is greater than 13, that means yes, the 0 does work. That means all of my solutions are on the inside. So the answers are on the inside of the two critical points, which means that I need to write them together as a compound inequality. So it's either going to be option A up here or option D down there. Remember, the smaller number always has to be to the left. The bigger number always has to be to the right. So it is obviously D. And we are out of time, so we're going to do number 20 on the next video.